The easiest step is to calculate N2 from the given volumetric flow rate. So we know V equals to 225 liters per hour, thus N2 equals to 225 liters per hour times with the density of water 1 kg per liter, and we want it to be in kilomole. We convert it into kilomole kg, and you do the calculation. 225 divided by 18, and let's see if we eliminated, no, kg per kilomole, sorry, so we eliminated, so we are left with the unit kilomole per hour. It's 12.5 kilomole per hour. That's N2, right? And then we can also do air balance, because air only comes this way and this way, and not this way, right? So air input, air output. There's no air output here, no. So air balance in equals to out. Air balance in is 90% of N1 equals to whatever air is coming out is N3. So N3 equals to, not yet. And then we can do a water balance. In this one, we can use the information where 95% of water is condensed, i.e. 0.95 of the water fed into the condenser. How much water is fed into condenser? So 10% of N1 equals to N2. And N2, we have found out its value is 12.5 kilomole per hour. So N1 is then 131.579 kilomole per hour. So from here, we can find N3, right? So N3 equals to 0.90, N1 equals to 0.90 times 131.579. Okay, take your calculator. 0.9 times 131.579 equals to 118.421. 118.421 kilomole per hour. Next is N4, i.e. the kilomole of water in the outlet gas stream. So to do that, you have several options. One is to do overall balance, i.e. N1 equals to N2 plus N3 plus N4. So you already know N1, N2 and N3, so you should be able to find N4. Another option is, 95% of water is condensed in the condensate, thus 5% of water from the feed must come out in the outlet gas stream. So you can do that also. N4 is 0.05 times 0.1 of N1. So 0.05 times 0.1 times 131.579 equal to 0.05 times 0.1 times 131.579, 0.6579, 0.658. The unit would be in kilomole per hour. That's N4. Well, you can check the value if you do the overall balance. So N1 131.579 minus N3 minus N2 minus 12.5 minus N3 118.421. equal to 0.658. So yes, it's balanced. I mean, we got the right answer for both methods. Okay, those are your N3 and N4. Next, the composition. So, composition of the outlet gas stream. Alright, so N3 equals to 118.421 kilomole per hour of air, and N4 is 0.658 kilomole per hour of water. And this air, 21% is oxygen and 79% is nitrogen. So you can calculate the composition in terms of percentage of oxygen, percentage of nitrogen, and percentage of water. How do you do that? Well, actually you can do it yourself, but for the sake of completing this tutorial, so oxygen, it's 0.21 times 118.421 divided by 118.421 plus 0.658 times 100% equal to 0.21 times 118.421 divided by 0.421 plus 0.658, and times 100 is 20.9%, and nitrogen would be 0.79 times 118.421 divided by 118.421 plus 0.658. Alright, there we go. We just change the number. 79 times 100. 78.6 times 100% equals to 78.6%. And H2O, you can either 100 minus this and you get the percentage, or you can also calculate if you are feeling diligent. Okay, so that would give you 658 divided by 658 plus 118.421 and times 100, it's only 0.6%. Okay, or if you just calculate 100% minus 20.9% minus 78.6%, would get 0.5. Okay, so that's the end of tutorial for question number 2.